this is problem, or page 48, problems number 1, A and B. So basically both A and B are log reviews where we're trying to isolate x, finding x in terms of A. So that means getting x on one side and A on the other. So basically we have a to the x equals 10 raised to the power of quantity 2x plus 1. The problem is we have x's in both exponents. That should trigger something for you, and that word that should be triggered in your mind is a logarithm. So we want to get this into a form that we can use. So we're going to start by using logs because that will help us. So I'm going to take the log of both sides. Okay. And now I'm going to use the rules, more of the rules of logs, where it says if we have the log of some base, or if we have the log of something, some value, raised to an exponent, that exponent can be rewritten out in front of a log. This is one of those properties of logs that we memorized, and I'm sure some of you were thinking, wow, when am I ever going to use that property? But this is when. Like, this helps us simplify the problem. Okay, so I rewrote these with the exponents out in front, and that's actually helped us out a lot. On the left side, we can't really simplify x log of a because, well, that's what it is. There's nothing to simplify. On the right side, however, we can simplify log of 10. So basically, the base here, since it's not written, is we're using just log of base 10. So 10 to what power makes this 10? And that would be 1. So this actually has a value of 1. So 1 times quantity, 2x plus 1 is 2x plus 1. Okay, so at this point we need to get all the x's together, and we need to get a and everything else on the other side. So my first step is I'm going to subtract 2x from both sides, because if I want to get the x's together, I have to have them on the same side. Alright, and then we're going to factor, because we have x in both terms, so that means we can factor out the x from each of these. So I'm going to pull x out front. So I end up with x times quantity log a minus 2, that equals 1. Since I'm trying to find x in terms of a, that means that I need to have x by itself on its own side. So I'm going to divide both sides by log of a minus 2. So x equals 1 divided by log of a minus 2. And that is your final answer for this problem. Oops, I almost crossed out. Alright, so part B, there's lots of right ways to do this, and I did this in another way that I think was harder. So I'm going to show you the way I think is easiest. So if you remember from part A, we kicked the exponents in front of the log to kind of help us simplify. In this case, we already have an exponent in front of the log, so I'm going to kick it back because I want to get rid of that coefficient. So if you separated the 2x, like wrote two different logarithms, it would work the same way. This is, I think, just a little easier, fewer steps. So we're going to say the log of quantity 2x squared equals 1 plus the log of a. And now I'm going to go ahead and simplify that because this 2 applies not only to the 2, but also to the x. So we end up with log of 4x squared. So I just applied the exponent to this term right there. Okay, so now I have log 4x squared equals 1 plus the log of a, and this is right where we want to be. So if you'll remember from when we studied these initially, if there's not a number written here as the base, we talked about on the last problem, we're in base 10, so we're going to say 10 to the 1 plus log of a power. So remember, we're switching this from a log now to an exponent, so this is the property, equals 4x squared. Okay, and so now what we're going to do is we're going to rewrite this term as a composition of two multiplication, they're not two terms, two products. So when we have 1 plus something or 1 minus something, we can use the exponent rule to do that. So this really becomes 10 to the 1 times 10 to the log of a. So remember, when you have a common base and you have things that are multiplied, you can add the exponents, right? And it works backwards. You can do the same thing. And undo the addition by multiplying them together. So my next step is going to be dividing by 4, and be careful here, you cannot reduce your exponents at this point, or your bases, because if you, well, you could, but we're going to leave them as 10. So this becomes 10 to the 1, which is 10, times 10 to the log of a over 4 equals x squared. So one more simplification before we go. So basically, 10 to the log of base 10 of a is a. So anytime you have 10 to the log of base 10 of something, you're left with something. And that's just another property that we're reviewing here. So this becomes 10a over 4 equals x squared. And I should go back and say you could reduce both of these. I think it's easiest to leave it in base 10 until you're sure that you're done, because base 10 is, I think, a pretty easy one to deal with. So I have reduced the 10/4 to 5/2 a equals x squared, and I'm going to take the root of both sides. Oops, not very neatly, I might add. So we end up with 5a, the root of 5a over 2, which equals x, and that is your final solution.